Alright, I'm back working on this little organ amp. I finished. He has a twin brother or twin sister, whichever. And I finished working on that one. That one's right over here. And I've got a little issue with that one. I'll try to address that in a bit, but first, before I do that, I want to take some measurements off of this amp to see what the power output is, I guess, the maximum power output before clipping. I'll just be looking at it on a scope. I might take an actual distortion measurement using the Heath kit, but I'm not that interested in precision here. I just want to see where it clips, and I'm also interested in seeing what the frequency response is of this amp. So I'm going to do that first. I'm working on my speaker project here. I built one of these in the past, and now I want to build a stereo pair. I really like full range speakers, so I'm just I bought this speaker, but I'm going to be using boxes and other parts I have laying around just to build a couple of nice full range speakers for the bench here. Or maybe if they're really nice, put them somewhere in the house in a room. So I'm starting out with this cigar box. Not the greatest box in the world to use as a speaker enclosure, but I have a whole mess of these laying around. I use them for just about everything, for storage of tubes and so makes a nice, kind of a neat little box for a speaker. So the first thing I need to do with this, let me put this, is to caulk the interior. Just do a little caulking and then set that aside to dry, and just do a little bit each night on that. I have the port and the terminals. So let me go ahead and get some caulk in here and let this dry, and I set these parts aside. I'll set these over here. Okay. Alright, let me get some caulk on there, and then we'll turn to this amp and see how good or how bad this amp really is. And then I want to go to the twin amp and discuss the problem. That's where the interesting part comes in. Whenever there's a problem, whenever something doesn't work right, that's what that's what I really enjoy about the hobby. Most people dread, when things don't work right, but I really appreciate that. Usually I'm able to fix them, sometimes not. Depends on my level of frustration whether I want to trudge forward with the repair. But I'm really interested in building a stereo pair or two mono blocks with these, if they turn out to be worth doing, just for the exercise of it. So we go ahead and get some caulk in here, and then turn to the measurements, and then turn to the problem with the other amp. Alright, I've got the amp hooked up to, I should say the output transformer. The speakers are hooked up to one of my two 8-ohm wire wound resistor dummy loads. I'm taking a true RMS voltage reading off of the across the dummy load, as well as an oscilloscope reading. And as a signal source, I'm using this function generator. Now, if I was going to be doing really serious total harmonic distortion measurements, I would not use a function generator because it itself produces quite a bit of distortion just by virtue of the nature of how it makes the sine wave. If I was going to do a serious THD measurement, I would use an audio oscillator, which I have. It's this portable oscillator right here. It's very low distortion. But I'm not going to be doing any serious THD measurements tonight. I'm just going to do it visually. Now it is noteworthy that the output tube, let's see, the particular output tube being used in this amp, which is the 50C5, which is a power pentode beam, can, under typical conditions, produce 1.9 watts at 9%. Neither of those specs are very impressive, but when you put things into perspective, all this amp had to do was to power a speaker in an organ, to acceptable levels, and I'm sure it did a fine job at that. I'm going to be putting this to use, maybe, putting this to use for powering speakers for playing music, audio. But this amp may prove to be pretty unacceptable for that job, but I'm just doing it to experiment. So let's start by before I try to see what happens at 1.9 watts, let's just take a look at what's going on here. Currently, now this has been running for roughly half an hour right now, so these tubes are heated up and everything internally is as hot as it's going to get. So let's take a look at what's going on right now. I'm at 1.2 volts RMS, which I can't do numbers in my head, so I'm going to run that. As far as power goes, that's 1.2 squared divided by 8 ohms, so that's 0.2 of a watt, which is pretty much nothing. And as you can see on the scope, we are getting a nice pure pure enough sine wave. It's not distorted in any way. So I'm going to go ahead and hold the camera on the scope, and I'm going to turn up the volume. Volume on the tube amp itself, which is this volume knob here, and I have the tone control all the way clockwise, which is the highest setting for treble, and I'm inputting 1 kilohertz right now, actually 923 hertz, close enough. So let's start cranking this up, and you can start to see right there's clipping. Let me reset the scope here, turn it down some. So let's find out at what point it clips. Now you can start to see, that's a pretty decent sine wave. It's a little asymmetrical, but decent enough. Now it's really starting to get asymmetrical, and then there's the clip right there. So I'm going to back it down off the clipping just a little bit right there, and then let's see what we have. That's 2.7 volts. So let's see what that translates into for as far as watts go. 2.7 squared divided by 8 ohms is roughly 1 watt. So really, you can't call this more than a 1 watt amplifier. It's clipping asymmetrically. It's clipping on the top first. Look at that. Oof. So this is about a 1 watt amplifier. Let me back it down to which 1 watt would be fine with a super efficient speaker at a reasonable listening level. But let me just back it down. Actually, let's take a look at the fast Fourier transform and see what's going on there. Let's see. Okay. So there's our fundamental. there's our fundamental right there. And I'm going to start cranking up the volume. Well, let me turn it down first. Okay, so I've turned it down. Let me turn it all the way. Okay, there we go. Now I'm going to start cranking it up, and there's you can watch the fundamental rise. And right now, the fundamental is going to be at 923 hertz. And then right here, you can just start to see the second harmonic peaking up and rising faster than the fundamental. Right there, they're 20 dB, 20 decibels apart. And at that point, now second harmonics are okay. They're acceptable to the ear. Third harmonics are not. Odd harmonics are not. But they're 20 dB apart. So let's that's 0.9. So that's about 1 volt. And it's about a 1/8 of a watt. So it's basically one. I don't know why I ran that number. It's about 1/8 of a watt. You start to see that second harmonic peaking up, and I'm going to start cranking it up more. There's the third harmonic coming up, and then you'll see at some point all of a sudden there's a mess of them. Now right there's just a ton of harmonics. Let's see what the waveform looks like at this point. You can see that's the major clipping. So let me back it down to the point where we don't see, okay, there's no clipping there. Let's go back and look at, so I'm just going to rotate the volume knob. That's where it starts to clip big time right there, and then not clipping right there. So really this amplifier is good for less than a watt, 3/4 of a watt and down. So at half a watt, this still could be acceptable. Let me remove the signal source because there was a little bit of a hum. So right now I've turned off the signal generator, and let's go back to the scope and see what's doing. Okay, now there's no signal in, so input, and so this is what I'm seeing across the speaker right now, and I guarantee you it's something like 60 hertz. Let me see, where's the measure button? Measure, and there it is. It's 59. It's 60 hertz. So there is a 60 hertz source of hum. It's very low in level, 43 millivolts. RMS, but nevertheless it's there. But for an amp like this that doesn't have a power transformer, it's a very primitive amp, that's to be expected. So this is not bad. I'm still on track for wanting to make a couple of mono blocks to power my little full-range speakers. But as I mentioned earlier, I was working on its twin brother, and the twin had an issue with significantly more hum, and when you turn the volume up with music, you reach a point where the amp becomes unstable and makes a terrible noise. It goes into some kind of an oscillation. Maybe I'll show that. I have not scoped it. I don't know what's going on yet. The first thing I'm going to do, because this amp works so flawlessly, the first thing I'm going to do is switch the tubes around between the two amps and see if that fixes it before I start probing around in the other one. Let me, since I've run this through a few tests, let me hook this back up to some music and make sure it still works well in that regard, and then I'll crank it up, we'll listen to it, and then I will hook up its twin brother, play some music through it, and I'll hopefully be able to sample the problems that I'm having with it. Hopefully that'll come across on the camera, so you can see the problems, and then we'll proceed to try to get those fixed. Okay, so I've hooked this the amp that I just tested up to a speaker, and it sounds just fine. I don't hear any distortion. This is coming from a radio station, from a boom box, so it's not, you know, not the best source. I just want to confirm that I don't hear any. Having a hard time finding stations tonight. It's about 3 in the morning. I guess a lot of stations sign off still. Let's see how this sounds.
Put me on the train, send me back my home. Couldn't live without you when I tried to roam. Put me by the windows, let me see outside. Look at all the places where all my family died. 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 Leave me by the churchyard, leave me on my own. The storm will come and take me back to my old home. Put me by the window, let me see outside. Look at all the places all my family died. All my family died. All my family died. All my family died.
Alright, so I'm going to turn this off and hook up the other amp, the one that I had problems with it when I initially started it up, and let's listen to that one and see if I can recreate the problem. Alright, just now hooked it up, and the tube's just now warmed up enough to the point where sound started to come out.
Slavic Soul Party and No BS Brass. Doors open at noon with
I think this tube is probably not original. It's not the same brand as the what was it, a 12 AT6? Yeah, I'm sorry, it was 6 AT6 triode. So I think this has been replaced. I did not test these three. This is the other amp. I took a leap of faith and did not test these tubes. I just did the capacitor upgrade on this one. Well, so far so good. Again, this signal source is the radio out of the headphone jack. So I'm going to continue to let it warm up, because before it started humming. But I did do one thing that might have made a difference, and I'll talk about that in a minute. Let me let it warm up and see if I can recreate the problem. Okay, so far so good. It's been this amp has been playing roughly 15 minutes, and I'm not able to reproduce the same problem I had earlier, which was seemed like some instability, some oscillation. I'll tell you what I did that might have fixed that. It's the only explanation I have. But anyway, I finished caulking the inside of my cigar boxes for my speaker construction. So I'm going to let that dry overnight and put the top on it so that it holds its shape. And we'll drill some holes eventually. Okay. Let's keep this going. Well, I don't know. This sounds pretty good. I'm not hearing the same instability or the same 60 Hz hum. What I did is there are, and I'm guessing this is what fixed it. I noticed that there are these little wires. Well, you know what? I need to disconnect this so I can scope it. So I'll show you from the back side. I don't want to. Let me disconnect this and I'll get it ready to hook up to the scope, and I'll show you from a different angle here. Alright, now there are, where's my light? Looking for my little flashlight thing. There are the wires that come out of the output transformer right here and there. They're the kind of wires that have coating on them, but they're so old. And the one wire was touching the other wire, and both wires were touching the housing. And so I just separated them so that each wire is not touching a thing. They're just sort of freestanding by themselves, and that seemed to correct the problem. Yeah, and that was causing the instability. Interestingly, also, it looks as though this is a zero negative feedback, or at least zero global negative feedback amplifier, because there's no wires connected to the output transformer that are fed back to anywhere else earlier in the circuit. So there's probably a little local feedback here and there, but certainly no global. I like that. That's good. Okay, let me get this ready. We'll look at it on the scope and see if it's equivalent to its twin brother. And then we'll discuss how to get these things ready to actually use and make them safe. Right now they're without a power transformer, and there's a couple of they're inherently unsafe for a couple of reasons. And I think one of the things I want to do is hook these both up to an isolation transformer so that they're both powered from an isolation transformer, as well as have fuses going to both. But I'm going to do that external to the box here. I'll do that as part of the chassis that these are going to be mounted on, but I'll do it external to the box. Alright, let me get this hooked up to the scope. Alright, this amp is now hooked up to the signal generator as the input, about a 1 kilohertz sine wave, roughly. There we go. Not important. 8-ohm wire wound resistor dummy load hooked up to an isolation transformer as a power source, 120 volts, and it's hooked up to our scope. You can see it's a bit wobbly, definitely being modulated by some 60 hertz noise, no doubt. But the signal looks good. Now, right now, let's do what we did before and crank it up to clipping. There's clipping, and we back it down, and 2.6 volts. I don't remember what it was before, but what's that power wise? 2.6 times 2.6 divided by 8. A little less, 0.84, 0.85 watts. So, just like before, roughly, getting close to a 1 watt. Clips a little bit differently than the other amp. But let's go ahead and remove the signal by turning the power off to the signal source and do an auto set and see if we can see the noise. And ignore that yellow channel, that shouldn't be on. Turn that off. And now looking at the red signal, that's going to be 60 hertz. Let's do a measure, and it's 60 hertz. Yeah, so that's about the same amount of noise. Well, this is 64 millivolts, so a little bit more. I think in the other amp it was 40 some millivolts, but that's our just our 60 hertz noise. So yes, this is good. Now I'm going to hook this and its brother up. Go ahead and get the cover back on and hook both of them up as a stereo pair and listen to them through the speakers. Alright, I've got both amps. Now this is interesting. Starting to hear that noise again out of the right amp. Maybe it's the speaker. I've got both amps. The left amp is hooked up to the left speaker, and the right amp is hooked up to the right speaker. And I'm starting to hear that 60 hertz noise out of the right speaker that I heard before. Well, I'm turning the volume up without a signal. Now, oh, okay. That's the left one, and I'm turning the volume up. Okay, the right one. Okay, they both behave similarly. There's definitely more noise out of the right one, but I measured more noise out of the right one too. I measured 20 more millivolts per channel out of the right one. Both of them have a little 60 hertz noise. But, okay, let me turn this up about a quarter of a turn. About a quarter of a turn on that one. Put some signal into it. I think they're out of phase. We'll turn the right amp off and switch speaker wire back on. Okay. Yeah.
Internet stream.
So I've got my noise back. It's worse now. That's coming out of the right speaker. Now watch the left one, the left amp. I'm going to turn that one off. It's the right one, the one I was having problems with earlier, but I couldn't reproduce it by measuring. We turn the volume down. Noise goes away. So there's some, with the volume down it's not there, so the noise is being introduced early on, and it's being amplified. But I don't know why, I'm gonna switch speakers here, turn this off. It wasn't doing it the same out of the other speaker. That wouldn't make any sense if the speaker has anything to do with it, but I'm just gonna try, see what happens. Just switch speakers. This shouldn't make any difference at all. Okay. Let it warm up. Yeah, it's still doing it. Not the speaker. Alright. I'm going to unplug it from the power strip where it is now and go for the isolation transformer like I had it before. Still the same. I wouldn't expect that would make a difference. So this 1 amp has a lot more noise. Significantly more. That's too much. That is too much. No one wants to listen to that. Now at low levels you can barely hear it, but as soon as you start turning the volume up you get it. Was not having that problem with the other amp, so I'm not sure what the deal is here. Just check the connection of the headphone. Alright, that's something to troubleshoot in the near future. I'm done for the night. Both amps do work. Too much noise in one of them, 60 hertz hum. You know what? I gotta do this. I gotta change. I know that this left amp works fine, the right one doesn't. I've just gotta change tubes. I don't expect that's gonna make a difference. These tubes work, and I don't. But I'm gonna go ahead and do it. I gotta let's let these cool down a second and switch them out. Change them directly, left to right, right to left. Okay, I've just finished switching the tubes. So my known good tubes are now in the amp with too much hum, and I haven't switched them. I just have the old tubes laying out right now, and I'm letting the amp warm up, and we'll go ahead and crank up the volume. Got a little bit of hum. Yeah, it's about like before. Alright, it's not the tubes. It's something else. Okay, I'm done for tonight. I'll troubleshoot this later, but I'm glad both of them work. I was going to do some frequency response, but I don't really care. They sound reasonably acceptable for what they are. I just want to fix the hum in this one, just to see what's wrong. It's really hard to do. I don't have a schematic. I tried to make one some time ago. It's kind of messy right now. I gotta really fix it up a little bit, but I think the best thing to do is just start tracing the signal. Kind of look, one side will be the signal from the good amp, it doesn't hum, and the other side will be the signal from the bad amp. And we'll just trace them both side by side and see at what point this 60 hertz gets introduced, and see if we can do something about it. So that's a project for another day. Thanks for joining me this evening. Take care.